Hello, in this video we will go over trig substitution for calculus 2. So calculus 2 trig substitution. So when you're going over this lecture, ask yourself when to use trig substitution. Um, Basically, when the integrand contains a binomial inside a radical or raised to a constant, we can use a trig substitution involving Pythagorean theorem along with SOHCAHTOA and other trig identities. Uh, in trig, you're going to take a polynomial and turn it into a trig. Remember what your final answer will be in terms of your original integration. So if you're in theta, your final answer will be in theta. If your answer is in x, your final answer is x. So what makes trig substitution makes it a little bit difficult or more work is because you have to know the Pythagorean theorem, SOHCAHTOA, and some trig identities. So it's a lot of trig stuff. Okay, so let's go over some trig identities and properties. So you've probably seen this one, sine square theta plus cosine square theta equals 1, right? That's Pythagorean identity. Sine 2 theta could also be expressed as 2 sine theta times cosine theta. Sine square theta could also be expressed as 1/2 minus 1/2 cosine 2 theta. Cosine square theta could be expressed as 1/2 plus 1/2 of 1/2 cosine 2 theta. And if you need to review SOHCAHTOA, here's a right triangle. It's just a little riddle to remember the sine, cosine, and tangent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Okay, so those will come in handy when we do these problems, so it's good to know. Pythagorean theorem is a squared plus b squared equals c squared. A is the square root. If you want to solve for just a, square root of 6b squared minus b squared. If you want to solve for small b, it's square root of c squared minus a squared. If you want to solve for small c, it's square root of a squared plus b squared. Okay, trig substitution for integrals. So this is something you need to know. So if you have the square root of b is a constant b squared minus ax squared, ax all squared, you're going to let x equals b over a times sine of theta. And it's basically, so if your problem looks anything like this, it's going to equal to this. 1 over a times sine inverse of ax over b. Okay? If your integral problem has anything with the square root of b squared plus a squared, for example, if it looks anything like this, it is going to be 1 over ab times tan inverse of ax over b, where you let x equals b over a times tan theta. Okay, so you need to know these rules, so go ahead and write it down. And then the third one is if your integral has a square root and then it has like a constant x squared minus a constant squared b squared, you're going to let x equals b over a times secant theta. And cosine theta is b over ax, and secant theta is ax over b. So yeah, go ahead and write those 3 rules down because we're going to need those when we do these problems. Okay, here's rule 1. Here's rule 2. And here's rule 3. Okay, so now you know the rules and some trig stuff. I'm going to start with example 1. So in example 1, it says evaluate using a trig substitution. So we have this square root of 1 minus x squared dx. So if you recall, if we have a square root and then a constant minus ax squared, it's going to be this rule. So this rule is very similar to this rule, b squared minus ax squared, where x is going to be b over a times sine theta. Okay, so as you can see, we have a minus in the middle, we have a square root, we have a constant squared, right? And then we have like invisible constant times an x squared. So it definitely looks like this. So we're going to use this rule. Okay. So if that's the truth, if that's the case, our x is going to be over a times sine theta. So what is our b and what is our a? So my b, what number squared? Because this number here is b squared. What number squared gives you b squared? Or what number squared gives you positive 1? 1. And a is, so what? There's like an invisible one. So what? Yeah, it's like saying 1x squared, right? 1x squared is the same thing as x squared. So yeah, my a is going to be 1. Okay, so then we solve for x, so it's going to be x equals b over a times sine theta. So my b is 1 over 1 times sine theta. So x equals sine theta. Then what you're going to do is draw your triangle. Yes, we do have a triangle. Here's our right triangle. Here's your theta. And okay, so according to this, you're going to need your subtotal. We said that x equals sine theta, right? Or x over 1 equals sine theta. You could rewrite this as sine theta equals x or x of 1. So what is sine theta according to subtotal? So sine is opposite over hypotenuse. So this x is your opposite. This one is your hypotenuse, right? So here's your theta. Opposite is x. The hypotenuse is 1. Now I gotta find this, before I go any further, I gotta find this missing leg. So you gotta use Pythagorean theorem. So one of my leg is x, so x squared. I don't know my other leg, I call it b. And then my c is, my hypotenuse is 1. So it's x squared plus b squared equals to 1. And then go ahead and solve for your b. So you're going to subtract x squared. You get b squared equals to 1 minus x squared. Solve for small b by taking the square root of both sides. So b is square root of 1 minus x squared. Okay, we're going to need that. Okay, so this missing side length is now you're going to replace. We're going to need the square root of 1 minus x squared. Okay, so then we got to do some kind of substitution. We said that x equals sine theta. Go ahead and wherever you see an x, go back to your original problem and replace x with sine theta. So we said that our original problem was square root of 1 minus x squared dx. And we said that x equals sine theta. Okay, now what you're going to do is replace your x with sine theta. So it's going to be Sine theta is x squared is going to be a sine squared theta. Wait, what about this dx? We don't have it. We have an x equals sine theta. So our dx is the derivative of this. So what's the derivative of sine? Cosine theta. Now where you are in d theta, right? So you're going to replace this dx with cosine theta d theta. Okay, so what did I just do? So let's kind of recap what we did. So our problem is square root of 1 minus x squared dx. You use one of your identities, and this looks very similar to this. So that means our x is going to be b over a times sine theta, right? Then we figured out our b and our a. Our b is 1 because 1 squares 1. And our a is also 1 because 1x squared is the same thing as x squared, right? And then x equals b over a times sine theta. So that's how I got x equals 1 over 1 times sine theta, which is sine theta. Okay. The next step is I draw on my triangle, and I use this trig to fill in the missing side. So if sine theta is x or x over 1, right? X equals sine theta is the same thing as sine theta equals x. We know that sine is opposite over hypotenuse, so this is why here's my theta. You can draw that. You can also draw the triangle this way. Either way works. So here's my theta. I did this way, and then here's theta. The opposite side is x, and the hypotenuse is 1. And then I got to find out this missing side length by using Pythagorean theorem, which I got square root of 1 minus x squared, right? Okay. Then what I did some back substitution. If x equals sine theta, I replaced my x with sine theta, so that's how I got sine squared theta. And then this dx, because we have it in terms of theta, my dx is the derivative sine, which is cosine theta d theta. So now I replace dx with cosine theta d theta, right? Okay, what do I do next? Clean it up. Use your trig identities to replace stuff. So 1 minus sine squared theta, I know that's related to my Pythagorean identity. Right? And then if I subtract minus sine squared theta, okay, so now I may replace 1 minus sine squared theta with cosine squared theta times it by cosine theta d theta, right? Now what can I do next? Well, I know the square root of a cosine squared theta is just going to be itself. So it's going to be cosine theta times cosine theta d theta. Okay. And then keep on simplifying. Cosine theta times cosine theta is cosine squared theta d theta. And use your identity. So if you recall, cosine squared theta can also be expressed as this. Right? So that's what I'm going to do. I'm going to replace this with that. So it's going to be 1/2 plus 1/2 cosine of 2 theta. And we still have this d theta. So now we can take the integral of this. So you could just take the integral of each term. So what's the integral of 1/2 in terms of d theta? 1/2 theta. What is the integral of 1/2 cosine 2 theta? well, 1/2 is a constant, so just take the integral of this, which is going to be, so factor out that 1/2, and what's the integral of cosine 2 theta? It is sine 2 theta over the derivative 2 theta, over the derivative 2 theta, which is 2. Let's see. Okay, so my final answer is 1/2 theta plus 1/2 times, this is 1/4, sine of 2 theta plus c. Okay, now can this be our answer? No. Why can't this be our answer? We started in terms of x, right? So our final answer should be in terms of x. So how do we do that? So yeah, this right here can't be our answer. Since it's in terms of theta. We need terms of x. So what do we know? Yeah, let's go back. What do we know? We know that x equals sine theta, right? From that's from the very beginning, x equals sine theta, right? So we need it in terms of theta. So how do I get theta by itself? Well, I could get rid of this sin by multiplying both sides by sin inverse, right? On the left side, it's going to be sin inverse of x. And then on the right, sin inverse times sine is theta. Okay, so theta could also be expressed as sin inverse of x. Good. And okay, so if we go back here, we can replace theta with sin inverse. So it's going to be, and wait, we have a sine 2 theta. We also know from our identities, we also know that sine of 2 theta can also be expressed as 2 sine theta times cosine theta. Yeah, that was a lot to remember, right? So we have a 2 sine theta here, and we know that's also 2 sine theta times cosine theta. So that's a lot of identities to know. Our final answer is going to be 1/2, and then we have a theta here. We said that theta could be also expressed as sin inverse of x. Plus 1/4. And then we replace sin 2 theta with 2 sine theta times cosine theta. And then you have this plus c. Now we kind of have a problem. Our final answer has to be in terms of x. This isn't sine theta, cosine theta. We need to go back to our triangle, and we got to figure out what is sine theta and cosine theta. So go back to your triangle right here. So what is my sine theta? So sine theta, here's your theta. Sine is so katoa is opposite over hypotenuse. So here's theta, opposite is x, hypotenuse is 1, and then what is cosine theta? Cosine is adjacent over hypotenuse, so it's going to be square root of 1 minus x squared over 1. Okay, so we're going to put that back into here. So you're going to replace sine theta with what was my sine theta? It was x. Yeah, so sine theta was equal to x, and then from my cosine theta was equal to it was square root of 1 minus x squared. Okay, so we got all that from that triangle. So it's going to be 1/2 times 2 sine theta is x times cosine theta is square root of 1 minus x squared plus c. And then what you could do is reduce the 2 and the 4. This becomes a 1. This becomes a 2. So my final answer is going to be 1/2 sin inverse of x plus 1/2 x times square root of 1 minus x squared plus c. That's your final answer. Do we have any boundaries? No, we don't. Okay. Yeah, so that was our final answer. Yep, that was a lot of work for one problem. Okay, let's move on to example 2. Evaluate using the trig substitution. We have the integral of 1 over 1 plus x squared, parentheses 1 plus x squared raised to the second power dx. So what do we know? It looks like we have some kind of partial fraction, right? So yeah, this right here, we got to simplify this before we go any further. No, so wait, you can solve this using a partial fraction decomposition, but let's use our trig substitution. So what does this look like? What rule is that going to be? Is that our first, second, or third rule? Let's see, we have, so this part right here is like saying 1 squared plus 1x squared squared. So you're going to use the tan. So it's this bottom right here. So that means we're going to use x equals b over a times tan theta. So my b is going to be 1, and my a is going to be also 1. So it's going to be 1 over 1 times tan theta. So x equals tan theta, or you could think of it as tan theta equals x over 1, right? Okay. So now we're going to do our triangle. our right triangle, put theta here. So if tan, let's use our SOHCAHTOA thing. Okay, so if tan theta is x over 1, so tan is opposite over adjacent. So here's theta. Opposite is this side, so that's x, and then adjacent is 1. I gotta find this missing hypotenuse by applying Pythagorean theorem. Okay, so A is x, B is 1 squared. So this is going to be x squared plus 1, c squared. And then solve for c by taking the square root. So c is a square root of x squared plus 1. So this missing hypotenuse is square root of x squared plus 1. Okay. Now what? We got a triangle, we found our missing sides. Let's do some substitution. So if you recall, our problem was 1 over 1 plus x squared, all raised to the second power, times dx. So we said if x equals tan theta, let's go ahead and substitute that back in. So wherever you see an x, plug in tan theta. So it's 1 over 1 plus tan. So tan theta squared is the same thing as tan square theta, right? Because you're squaring this x, and then you got to square it again. And then you see this dx, we have to put in terms of theta for now. So what's dx is the derivative of x. So dx is going to be secant square theta d theta, right? So you can replace this dx with secant square theta d theta. Okay, so if you clean this up a bit, it's going to be expressed as secant square theta d theta. And then what about this? Is there some kind of identity we can use? Yes. One of your Pythagorean identities. We know 1 plus tan square theta is equal to secant square theta. So you're going to replace that with secant square theta. And clean this up a bit. So it's going to be secant square theta. What's secant square theta times raised to the second power? That's secant fourth. And then kind of clean this up a bit. Secant square over secant fourth is the same thing as 1 over secant square theta d theta. Use some more trig identities. Well, we have 1 over secant square theta. What do we know? We know that 1 over regular secant theta is the same thing as 1 over cosine theta. And then that simplifies as just regular cosine theta. Because we have a secant square theta, it's going to be cosine square theta. So this 1 over secant square theta is the same thing as cosine square theta d theta. Okay, now do more trig substitution. We know that cosine square theta is the same thing as 1/2 plus 1/2 cosine of 2 theta, right? So we're going to replace cosine square with theta with all that. 1/2 plus 1/2 cosine of 2 theta of d theta. Go ahead and take the integral of each term. So the integral of 1/2 is 1/2 theta What's the integral of 1/2 cosine 2 theta? So it's take that 1/2 out. The integral of cosine 2 theta is sine 2 theta over 2. And then don't forget the plus c. So we get 1/2 theta plus 1/4 sine of 2 theta plus d. Oh, that can't be our final answer because we're in terms of theta. What did we originally have? X. So our final answer has to be in terms of x. So we're gonna gotta do some substitution. So if you let me draw the triangle again. So our triangle was like this. Here's x, here's theta, this is 1, this is x, and then we found the hypotenuse, which is the square root of 1 plus x squared. What else did we know? We know that, we also know that x equals tan theta. We got to somehow solve for theta because, yeah, how do we solve for theta? Got to get rid of this tan. To do so, we're going to multiply both sides by tan inverse. Okay, so tan, this cancels, results with theta. Over here, this is going to be tan inverse of x. And then I'm going to replace my theta with tan inverse of x plus 1/4 times 2 sine theta. What do we know that sine of 2 theta is the same thing as 2 sine theta times cosine theta, right? So what we got to do is find sine theta and cosine theta. So what is sine theta? Sine is to what? So sine is opposite of our hypotenuse. So here's theta. Opposite is x. Hypotenuse is square root of 1 plus x squared. And then cosine theta is adjacent over hypotenuse. Adjacent is 1. Hypotenuse is square root of 1 plus x squared. So that's 2. And then sine theta is x over square root of 1 plus x squared. Cosine theta is 1 over square root of 1 plus x squared. If you clean this up, this would be 2x, and then on the bottom, this is practically the same thing, it's just square root. So what happens is the square root disappears, you're left with 1 plus x squared. So sine of 2 theta all becomes 2x of 1 plus x squared, and then plus c. Okay, so I guess you can express your final answer as 1/2 tan inverse of x plus 1/2 of x over 1 plus x squared plus c. Okay, part B says it's the same thing as part A, but now our boundary is from -1 to 1. So we kind of figured this out. So you can change the boundaries if you want, but I don't want to. We found the integral of this is that, so it's going to be 1/2 tan inverse of x plus 1/2 of x over 1 plus x squared. And then we're going from the boundaries -1 to 1. So if you put that in, it's going to be 1/2 tan inverse of 1 plus 1/2 of 1. 1 plus 1 squared is 2 minus bracket. And when you do all the algebra, you should get I4 plus 1/2. Okay. You could have changed the boundaries. You could have gone from theta and then replace, your theta, and then you would have your lower boundary would be -π/4 to +π/4. That's perfectly fine. Okay. Let's move on to example 3. Okay, example 3 says integrate. We have the square root of 25x squared minus 4 all over x. So we got to figure out which identity shall we use. So we have 25. So this right here looks very similar to the square root of ax squared minus b squared, where x equals b over a times secant theta, right? So what would be our a? So if you want to rewrite this as 5x squared minus 2 squared all over x dx, that means my a would be 5 and my b would be 2. So x over ba, so b is 2 and my a is 5. You have secant theta. Okay, then what we got to do is just kind of solve for secant theta because we're gonna use our triangle. So secant theta, just multiply both sides by the reciprocal of 2/5, which is 5/2. So 5/2 would be 5x over 2. So what is secant? If you recall, secant is the reciprocal of cosine. So the reciprocal of cosine would be, so this would be your hypotenuse, and then this would be your adjacent, right? So if you draw your triangle, your theta, your theta is here, so secant is the hypotenuse. So the hypotenuse is 5x, and then the adjacent is 2. Got to find this missing leg by using Pythagorean theorem. So leg is 2. I don't know my other leg. My hypotenuse is 5x squared. So 2 squared is 4 plus b squared. 5x squared is 25x squared. Subtract 4. And you get b squared equals to 25x squared minus 4. Solve for b by taking the square root. Okay, so this leg right here is going to be expressed as square root of 25x squared minus 4. Okay, then you're going to go do some back substitution. Our problem was this integral of square root of 25x squared minus 4 over x times dx. And we know that x equals 2/5 secant theta. So my dx, what's the derivative of this, is just 2/5 of secant theta times tan theta d theta. And then we said that x is this, so now we can do some back substitution. So what is, if x is 2/5 secant square, x squared is going to be 4 over 25 secant square theta. Okay, so that's what we're going to do. We're going to replace x squared with 4 secant square theta over 25 minus 4 all over x, which is 2/5 secant theta. And then you're going to replace my dx with 2/5 secant theta times tan theta d theta. Okay, clean this up. So over here, the 25's cancel, so now you're left with the square root of 4 secant square theta minus 4. And then, yeah, when you do the algebra, the 2/5 cancels in the secant. So yeah, when you do this, the algebra, oh, when you multiply this cancels, there you go. And then the secant theta cancels. So you still left with this tan theta d theta, and then all over 1. So you're going to simplify this as, so over inside the square root, is there something you can take out? Yes, you can factor out a 4. And then times it by tan theta. So any identities we can use? Yes, secant square theta minus 1 is the same thing. So we know that tan square theta is equal to secant square theta minus 1. So secant square theta minus 1 is tan square theta. And then times it by tan theta d theta. Okay, and then when you take the square root of 4 and the tan square theta, you get integral of 2 tan theta times tan theta d theta. And 2 is a constant, so you can take that out. So wait, you have a tan theta and tan theta, so that's going to be tan square theta d theta. And then you can use your trig identities. We know that tan square theta is the same thing as secant square theta minus 1 times it by d theta. And now we have to take the integral of each term. What's the integral of secant square theta? It is tan theta. What's the integral of -1 in terms of theta? It would be negative theta. And then because we took out a 2, we got to distribute that 2. So that is, yeah, and then plus c. But is this our final answer? No, we got to put it in terms of x because we started in terms of x. So here, let me redraw the right triangle. Here's my theta. And then here's 2 square root of 25 x squared minus 4. And then you have this 5x. So we need to find tan theta and theta. So we know that, yes, we were given tan theta is square root of 25x squared minus 4 all over 2. So if you wanted to solve for theta, it's going to be tan inverse of square root of 25x squared minus 4 over 2. My answer is 2. And then we said that tan theta was square root of 25 x squared minus 4 over 2 minus, and then theta was this whole thing, tan inverse of square root of 25x squared minus 4 all over 2. And then plus c. And then, oh yeah, we distributed that 2. So when you distribute that 2, you're going to get, so this 2 is canceled. So there's going to be square root of 25x squared minus 4 minus 2 tan inverse of square root of 25x squared minus 4 all over 2 plus c. Let's do one last one and then we'll call it a day for this lecture. Okay, so in example 4, we have this integral of dx over x fourth minus 4x squared minus 4. So what could we do? I don't see any identities now. So what I would have to do is kind of like go backwards, put this in factor form. So this right here could also be expressed as x squared plus 2 squared, right? Because when you FOIL this out, you're going to get this. So we can rewrite our problem as dx over x squared plus 2 squared. Okay, so now it looks very similar to one of our identities. It looks very similar to the square root of b squared plus ax squared, where x equals b over a times tan theta. Okay, blah, blah. Okay, what do I do? So, okay, so if that's the case, what is our a and our b? So my a, careful. So this is kind of backwards. Yeah, it's a bit backwards. You can rewrite. So this is like the same thing as this. Just be careful. It's the commutative property. So this is related to this, right? So my a is going to be 1. And then what do you think my b is? So this 2 is related to this. Careful. Think, what do you think your b is? So what number squared gives you 2? Yes, it's going to be square root 2, not 2, but square root of 2, because when you square radical 2, you get 2. Okay, so my x is going to be b over a times tan theta. So my b is square root of 2, my a is 1, and then you have tan theta. So my tan theta is the same thing as x over square root 2. Or you could think of it as opposite over adjacent. Go ahead and draw your triangle. Here's your theta. So if tan is x over radical 2, that means this would be x, and then the adjacent side is radical 2. Now I'm going to find the hypotenuse by doing Pythagorean theorem. So it's x squared plus radical 2 squared equals c squared. So x squared is x squared plus radical 2 squared is 2 equals to c squared. Solve for c by taking the square root of both sides. C is the square root of x squared plus 2. Now we're going to do some back substitution. If you recall, our problem was dx over x squared plus 2 squared. And we said that x is square root of 2 tan theta. And let's find our dx, because we're going to need that. The derivative of x is, well, radical 2 is constant, so bring that down. And then the derivative of tan theta is secant square theta d theta. And then just substitute it back in. So you can replace x with this, radical 2 tan theta, and then you can replace dx with that. So go ahead and turn that up. Dx is square root of 2 secant square theta d theta. And then over here, we're going to replace x with square root of 2 tan theta squared plus 2 squared. A square root of 2 when you square this, you should get 2 tan square theta plus 2. And then we're going to square that. So that's going to be simplified as square root of 2 and then it looks like you could factor out a 2 right here. So this will be tan square theta plus 1. And then this is an identity, right? That's a secant square. So that's going to be 2 secant square theta squared. And you still have this d theta. Okay, now go ahead and let's see what we do. Oh, clean this up a bit more. So this is going to be square root of 2 secant square theta. And then when you square this is going to be 4 secant to the 4th theta d theta. And then I guess this radical 2 over 4 is a constant, so that's going to be radical 2 over 4. And then secant square theta over secant 4th is 1 over secant square theta d theta. And 1 over secant square theta is the same thing as cosine square theta d theta. And what else do we know? This is an identity we know. We know that cosine square theta is the same thing as 1/2 plus 1/2 cosine of 2 theta. So that's what we're going to do. We're going to replace that with 1/2 plus 1/2 cosine of 2 theta d theta. And then just take the integral of each term. So in the integral, 1/2 is 1/2 theta. The integral of this is 1/2. The integral of cosine 2 theta is sine of 2 theta over 2. Let's see. And then we have to still factor out that radical 2 over 4. So when you do all the work, you're going to get radical 2 over 8 theta plus radical 2 over 16 sine of 2 theta. Let's see. This can't be our answer because we were in terms of x. So we got to do some convert it to x. So what do we know? We know tan theta is the same thing as x over radical 2. And then if you want to solve for theta, you're going to multiply both sides by tan inverse. So theta is going to be tan inverse of x over radical 2. Okay, so it's going to be and we also know that sine 2 theta is the same thing as 2 sine theta times cosine theta. So let's kind of draw a triangle because if we need to find sine theta, cosine theta, we need our triangle. So if you recall, here's a triangle. You said that x was x tan. We know that tan theta was x over radical 2, so that is TOA. So opposite over adjacent. Okay, here's your theta. This would be x, which would be opposite, and then adjacent would be radical 2. Find the missing hypotenuse by applying Pythagorean theorem. So it's x squared plus radical 2 squared equals c squared. So x squared is x squared. Radical 2 squared is 2. C squared. Solve for c by taking the square root. Okay, so then just, yeah, so our theta is that, wait, we have our theta, and then we need to find sine theta, because that's part of our problem. So let me write it out. We have radical 2 over 8 theta plus radical 2 over 8, and then we had a 2 sine 2 theta, which is 2 sine theta times cosine theta. Let's see. It's like radical 2 over 8. If you clean this up, this is going to be radical 2. Wait, this should have been 16, and then this would be 8. Then we got to find what was our sine? So we need to find our sine theta. Here's your theta. So sine is so opposite over hypotenuse, so it's going to be x over the hypotenuse is square root of x squared plus 2. And then my cosine theta is adjacent, which is radical 2, over hypotenuse, which is square root of x squared plus 2. So your final answer is going to be radical 2 over 8. And then you're going to replace theta with tan inverse of x over radical 2 plus, let's see. So when you do all that, you replace sine theta, cosine theta, your final answer is radical 2 over 8 tan inverse of x radical 2 plus x over, weird limit, is going to be, so this would be 2x and then 8, and then this is going to be x squared plus 2. Let's see, so when you clean that up, your final answer is going to be yeah, that's your final answer. Okay, so we will stop here.